Now, after checking the normality of the data, now you have to open the SPSS sheet of independent sample t-test, which I have sent to you. Yes. And the recording will be shared with all of you, okay? Those who have joined, recording will be shared. So yes, if you have opened it, so look, after judging that whether the data is normally distributed or non-normal. So if the data is normally distributed, so then you have to apply parametric tests. And if the data is not normally distributed, then you have to apply non-parametric tests. So again, I will go towards this first slide in which all the tests were written. So look, for t-test, peer t-test, and ANOVA, what you are doing is that you can't run these tests unless until you have one numerical variable. One numerical variable is must for to run independent sample t-test, ANOVA, as well as paired t-test. But for paired t-test, you have to compare with two continuous or two scales variable. But for independent sample t-test and ANOVA, what you are doing is that in independent sample t-test, you are comparing two groups means. The means of the two groups you are comparing, and similarly in ANOVA, you are comparing the means of greater than two groups. And then later on, we will say that what we will have to do for Mann, Whitney, Wilcoxon, and Pascal-Wallis. So now, first of all, you have to understand this thing that for independent sample t-test, you should have two groups, categorical groups, male or females, presence or absence, um, just like this. So if you are having two groups and you are having one continuous variable and you want to compare the means of these two groups. So let me show you here that male versus female. These are two groups, okay? This is categorical data, nominal. Inside the categorical, they are nominal. Now you are calculating the mean for independent sample t-test. What you are doing is that you are calculating the mean of males and you are calculating the female means of females. And after calculating them, you are comparing these two groups, that whether there is any difference in between the groups or not. Then when you will apply ANOVA, so there will be third variable as well. And then you will also check the mean of that variable. And then you will have to see that whether there is any difference in the means between three groups or not. So if there is a difference and statistically it is different, so you will say that there is a statistically significant difference. And if there is no difference, so then you can say that it has got no difference. So if you will open your this SPSS sheet, so here you will have one weight and you are having male and female gender. So now go towards analyze, compare means, and independent sample t-tests. So how you came to know that it is independent sample t-test? Because you are having only male and female. These are only two. If you had any third category, so then you will have to apply ANOVA. So here is independent sample t-tests. Now when you will go there, so you will now place weight in the test variable. And in the grouping variable, you will just place the nominal data which you want to compare. So here there is male and female. So then you have to define the groups as well. So if you see in the variable view that I have given male 1 and female 2. I have coded male as 1 and female as 2. So here I will put that coding of 1 and 2. Then I will apply continue. Confidence interval have to be 95%. And then you have to push the button of the continue and then you have to do OK. So once OK will be coming, so this is the results of independent sample t-tests. So now here you see that the most important thing about the independent sample t-test was that it compares the means of two independent groups to determine if there is a statistically significant difference between them and the assumptions of independent sample t-test while you are seeing a data. So you have to see that whether the data is following assumptions or not. So first assumption is that two groups have to be independent. There should be no relationship between these two groups. They have to be independent. So like males, average blood pressure is different as compared to females different average blood pressure. So these are two different groups. Then the numerical variable which you are testing has to be normally distributed. So you have to check that through initial tests. Then you also have to see that whether there is homogeneity of variances or not, that equal, there should be equal variances in the groups. So variances, I have told you in the right at the start that what variance is all about. So which test will show that whether the two groups are having equal variance or not. This test is known as Levine test of equality of the variances. So here I've written that it tests whether the variances of the two groups are same or different. Okay. So look, if once you have seen this independent sample t-test, so now first of all you have to see here this significance value you have to see first of all. So if it is greater than 0.05, it means that assumptions of equal variances have been applied. Because if this is less than 0.05, so you can't use this p-value, this one, two-tailed, then you will have to go towards this p-value and you have to just report this p-value in your research on in your thesis. So first of all, you have to see that whether the variances are equal or not. So variances are only equal when the significance level here is greater than 0.05. So if it is less than 0.05, then you have to go towards the second row and you will have to report this p-value. So this is the most important thing in the independent sample t-tests. So once you have seen that whether it is not significant, then you are assuming that there are equal variances among the group. Then you have to use this p-value for reporting. Now, how you will have to graphically represent it. So go towards graphs, legacy dialogues, bar, and then here you will apply simple summaries for a group of cases. Then you have to define it. Then in the variable, you have to place weight. And then in the category axis, you have to place gender. Then in options, you don't have to mark any of these options. And then you have to press continue and OK. So look here, you will find that there are two groups. One is male, another is female. These boxes are showing standard error of the mean. And now you can say that there is difference between these two groups and it is statistically significant. And this is how data interpretation is done in various styles. You can do in Vancouver, you can do in APS style. But generally the standard of this is that how you have to write it. So you have to take into account all these three boxes which are present here, 1, 2, and 3, and you have to just write. So this is the standard, and you can't do anything except you have to just learn this format for the independent sample t-tests, and then you have to write it like this. Okay. Now we will go towards pair sample t-tests. So I will go a little bit quick because we have to cover a lot of things in much less time. So paired sample t-test is basically on the same patients, but there is pre-test and then there is post-test, and you are comparing pre-test mean with post-test mean. So here you will not have categorical variable. Here you will have two numerical variables. And what will be the assumptions? Assumption are that these two should depend on each other. Because, for example, you are testing blood pressure of a patient before taking a drug, and now you are testing blood pressure after the patient has taken the drug. So for example, there are 10 patients, you are calculating the mean of all that 10 patients before they are taking a drug. And now after taking the drug, you are seeing after 1 hour the means of all those patients, that whether the blood pressure has increased or decreased. Again, the normal distribution has to be followed and the data should be continuous. That's the most important thing which will compare it from which it will separate from rest of independent sample t-tests and ANOVA. So look, here is BP before and after. Now, these are just raw values. If you see here in these values, 73, 10, so there is considerable differences among the values. So what you have to do is that you have to standardize all the values and you have to just correct all the values, so that at the end of the day, what you have to see is in this graphical representation, let me show you. So you have to make this graph, you have to take average of all the patients, and then you have to see that whether after taking the medication, blood pressure increased or decreased. So for making this uniformity, you have to follow certain steps. So I will share this slide with you, all of you, so you can also copy that, but I will go very quickly that how you have to do that. So look, you have to go to transform, compute variables, then you have to write difference, and then click type and label, and you have to push this button so that blood pressure before minus blood pressure after. So you create this differences among the value. Then you have to correct these values as well. Now go towards compare means, paired sample t-test, and then you have to place, first of all, you have to place BP before, then you have to place BP after, then go towards options, confidence interval is equal to 95%, continue. So in this way, you will get this three different results. So here, what result is given to you? A correlation, a descriptive statistics, and also here at the very end, it is shown that what's the mean of differences. So here, if you see here, the value before blood pressure, it was 69.48, and after it is 13.25. So this is a large drop in the blood pressure. So paired sample correlation, you have to see that there is no significant correlation before and after these values. So what does it mean? That changes in BP are not strongly related across individuals. They didn't all improve by the same amount. So for some, if you see, for some it's a big drop, and for some it's very less drop. So that's why the correlation coefficient is not significant. And then finally, you will have to see the t value, which is also known as critical value, mean, and degree of freedom. But definitely for you, what is important is that you have to see that whether the difference is statistically significant or not. So this is the mean value which you have to report, standard deviation, and then you have to report this p value, that yes, when we have just applied the paired sample t-test, there was a statistically significant difference between the groups and it matters. Okay, one more thing I have forgot to mention is that while reporting of the data, you have to be, if the data is normally distributed, so you have to use mean plus minus standard deviation. And if the data is not normally distributed, then you have to report the data with median. If you are reporting non-normal distributed data with mean and standard deviation, so you are doing it incorrect. So you have to use median and interquartile range or range. So this is very important while you are reporting the data, and different journals see such things as well. And if you have just reported the data was normally distributed and you are just giving median values, and if data is, for example, normally distributed, you are giving median, so that is wrong. So in reporting of the data, always see that whether that was normally distributed. So if it is normally distributed, use mean plus minus standard deviation. And if it is not normally distributed, you have to use median. So for generating graph um, in the paired sample t-test, so um, these are all formulas which I've written and which I will share with you. So definitely we will not go into that detail. So you can easily copy whatever I have written here after the workshop. So you can again go through all this, that how to make graph of the paired sample t-test. So this is how you have to build this graph. Okay. This is the differences between before blood pressure and after blood pressure, and this is the standard error. And then you can also try to change this color of graph. While double clicking it, you can change into gray, black, blue, whatever you want. And you can see that the differences in the blood pressure just graphically like this. So for data interpretation of paired sample t-test, this is a standard. So when you are using paired sample t-tests, you always have to report correlation as well, that whether there was correlation or not. And also then you have to see the p-values, and p-values when written in the form of 0.00. So you will not have to report like that p-value is less than 0.00. You have to use this p-value less than 0.001. This is a standard format of the writing. Now we will go towards ANOVA, or the analysis of variances. So it is comparing the means of three different groups. Okay. So it's a statistical method to compare means across three or more groups. And it tests that whether differences among groups means are statistically significant or not. So there are three types of ANOVA. One is one-way ANOVA, other is two-way ANOVA, and the third one is the repeated measures ANOVA. So for simplicity's sake, we are only using one-way ANOVA for this workshop. So you have a crystal clear idea that what one-way ANOVA is. Rest of the ANOVAs can be applied once you can understand one-way ANOVA. So in one-way ANOVA, just like independent sample t-test, you have to have three groups. In independent sample t-test, you had two groups, but now you are having three groups and one continuous variable. And in each group, you are just trying to find mean, and then you are trying to compare the means of these three groups. And once that comparison is done, so the computer generates the p-value in which it will tell you that whether there is any difference which is statistically significant between the groups or not. So again, you have to have this Levene's test will again appear in ANOVA test as well, just like in independent sample test. And you have to see that whether variances among the groups are similar or not. So for parametric test, independent sample test, and ANOVA, variances should always be equal. So here, if you see here, if you can open this um, SPSS sheet in which it is written ANOVA and Kruskal-Wallis test. So you have to see that look, one is weight and other is feeds. So high protein feed, medium protein feed, and low protein feed. These are three different groups. And you want to compare means among all these groups. So one is you are having a continuous value, and other is you are having that categorical variable, high protein, medium protein, and low protein. So go towards analyze, compare means, one-way ANOVA. Then in the dependent list, you have to place continuous variable, and in the factor, you have to place categorical variable. Then you have to go towards contrast. Okay, you will not check this polynomial because it will show you graphically the direction of the relationship, which we are not interested right now. We just want to see that whether there is difference or not. We are not going towards the direction of the relationship. The most important thing is the post hoc analysis in the ANOVA. So post hoc analysis should not be performed in the first go. The proper methodology of ANOVA test is that you don't have to apply post hoc right at the start. First of all, you have to see that whether p-value was significant or not. If there are differences between the groups, just like you are seeing here, if there are differences, then your next step is to apply the post hoc test, and you have also to report ANOVA just like this. First of all, you have to see that whether there are differences between the groups or not. So look here, when we had applied ANOVA, so there was statistically significant differences among the groups. So then I will go towards post hoc test and I will apply the post hoc test, because applying right at the start when you don't know is not the correct methodology, because first of all you have to know that whether there are any differences among the groups or not. Then the post hoc test summarizes in much deeper way that okay, p value is telling you that there is differences between the groups, but then it pinpoints that in between the groups which two groups are statistically significant and which are not. So here when you will open the post hoc tab, you will see quite a lot of tests. But when variances are equal, or you assume that variances are equal, so you have to apply the Tukey tests. And when variances are not equally assumed, so then there are multiple other tests which you can apply. So post hoc selection in one-way ANOVA, why use only Tukey test? It is used after finding a significant ANOVA result. It helps identify that which group pairs differ significantly. So it is only used when you assume equal variances, and when equal variances are not assumed, then there are certain assumptions which have to be met for applying other post hoc tests. But generally speaking, we apply simple Tukey test, which is not the Tukey's B test. We are applying the Tukey's test. Okay. Then you have to go towards option, click check descriptive, homogeneity of variances, and Welch test. Now, Welch test is also important to see that whether their equal variances are assumed or not. And then you have to also check the means plot as well. So in options, you have got um, different options, but now here you have clicked descriptive, homogeneity of variance, and Welch test, and means plot. Okay, so bootstrapping is done for the non-normal data when you are having small sample size and you want to extrapolate the results. Generally speaking, ANOVA is not used in our research in which sample size is 60, 100, 30 plus. Adequate sample size, you don't need to bootstrap. That is just for the very less sample size to try to extrapolate the results. So, okay, I will just turn off the meeting right now, and after 5 minutes, I will join from link number 3 for a description of this ANOVA test, and then we will also discuss non-parametric tests. So join from link 3.